Hi everyone, in this video we are going to discuss the term radioactivity. So back in 1899, Madame Curie actually coined the term radioactivity, and she introduced this word to society with a very, very simple but beautiful definition. And basically what she said is that radioactivity is the spontaneous emission of radiation by certain elements. Okay? And so when she introduced this, she basically said that groups of different elements can spontaneously just decide to emit radiation. And usually they do this by emitting a specific particle. And so the three particles we're going to focus on in this video are your alpha, beta, and gamma particles. And we can't discuss these without giving a shout out to the brilliant Rutherford, because he is the one who actually was able to identify what these particles were. So the first one we're going to do is talk about alpha particles. So an alpha particle is usually represented by either the little alpha symbol or by using helium. So remember, helium has 2 protons, and when we're talking about specifically an alpha particle, we're saying that helium has a mass number of 4. So whenever you look at this, I don't want you to say helium-4, I want you to say an alpha particle. Now, there's 2 things we need to know about an alpha particle. The first things first is that it has a +2 charge. Okay, 2 protons in the nucleus plus 2 charge. Now, the second thing is that it is very, very large. Of the 3 particles we talk about, this is the fattest one. It is the biggest one. The alpha particle is definitely the biggest. All right, so then let's move on to something slightly smaller, well, significantly smaller, which would be a beta particle. So now a beta particle can be represented in 2 different ways. We can use the beta symbol, or we can say it's an electron. And so now an electron usually has a charge of -1, and then we say it's very, very tiny, and so it has a mass number of 0. So the 2 properties here is that it has a -1 charge, and that it is teeny, teeny, tiny. So I'm just going to write tiny with an exclamation point, and hopefully you understand that it's tiny, tiny, tiny. Compared to an alpha particle, it barely exists. All right, so now the last one, which is the smallest out of all of them, would be considered a gamma particle. So now a gamma particle is usually represented with either the gamma symbol or this symbol here, same symbol, gamma, and we say that it has 0 for the atomic number and 0 for the mass number. So our 2 properties for this one is that we just say there's no charge, we say that there is no mass, and then the last thing I want to add for this is that it's usually associated with very, very, very high energy radiation. Very high energy radiation. Okay, this is dangerous. You do not want to be exposed to gamma radiation. So now, I just said the phrase gamma radiation, so I want to be very, very clear, because there's 2 different types of gamma radiation that we could be talking about. So if you ever hear someone say gamma nuclear radiation, you then know that they're talking about the high energy radiation that is from a nucleus. Okay, gamma nuclear radiation means that we're talking about radiation that was emitted directly from a nucleus. Now, alternatively, we could say that we have gamma electromagnetic radiation. Now, radiation. So now this is not from a nucleus. This is something that has been emitted from a star or maybe the galaxy, something like that. This has been emitted from outer space, okay, not from a nucleus. So gamma nuclear radiation can definitely happen here on this planet if we're having something from a nucleus, but a gamma electromagnetic radiation has to come from an outside source, so a star or a galaxy. All right, so let's see if we understand some things. We have 2 questions here. The first one, which of these 3 particles, so alpha, beta, gamma, is the biggest? And then I also want to know, out of these 3 particles, which one is the most dangerous? Go. All right, did you get an answer? Hopefully you did, because I just said it. So if you didn't get the answer, make sure you take a little bit better notes in the future, okay? So which of these 3 particles is the biggest? That's definitely your alpha particle. Which one is the most dangerous? Definitely your gamma particle. You do not want to be anywhere near gamma particles if you can avoid it. All right, the last thing that I'm going to do here is leave you with just a little bit of a fun fact. It's something that you definitely need to memorize. So all elements with an atomic number that is greater than 83 are going to be radioactive. So they can spontaneously emit radiation. So 83 is bismuth, 84 is polonium. So any element that is greater than polonium or higher is going to be radioactive. That's what we're going to leave you with today. Have a great week. Drink water.